All right, let's take a look at lesson 3.2, properties of parallel lines. In this lesson, we're going to look at the same type of angles, special angle pairs that we had when we had a transversal intersecting a pair of lines. Now we're going to look to see what happens to these angles when the lines are parallel. So, when the transversal does intersect these parallel lines, they're going to either be, the angles are going to either be congruent, supplementary, or both. Now the only place they'll ever be both is when the angles are right angles. So let's look at our first postulate, same side interior angles postulate. So if a transversal intersects two parallel lines, then the same side interior angles are supplementary. So if you look here at angles 4 and 5 and angle 3 and 6, they're on the same side of the transversal and they are on the inside of the parallel lines. So they are supplementary, which means that they're going to add up to equal 180. So angle 4 plus angle 5 equals 180 and angle 3 plus angle 6 equals 180. Next one is the alternate interior angles theorem. If a transversal intersects two parallel lines, then alternate interior angles are congruent. So if line M is parallel to line L, then angles 3 and 5 are congruent and angles 4 and 6 are congruent. They're on alternating sides of the transversal T and they're on the inside of the parallel lines. Now we have the corresponding angles theorem. So once again, if a transversal intersects two parallel lines, then their corresponding angles are congruent. So remember we talked about corresponding angles, there's 4 pair. So they're in corresponding position, like 1 and 5. They're both in the upper left-hand corner of the set of 4 angles. And so they're in corresponding position, therefore they are congruent. 2 and 6 are corresponding angles, they're going to be congruent. We have 3 and 7, and then we have 4 and 8. So notice that these are both acute angles here, and in this case they are congruent. So 1 is congruent to 5, 2 is congruent to 6, 3 is congruent to 7, and 4 is congruent to 8. And the last one, alternate exterior angles theorem. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. So once again, if M is parallel to L and T is our transversal, then angle 1 is going to be congruent to angle 7 because they're alternate exterior angles. And 2 is congruent to 8 by alternate exterior angles. So remember, as you look through all these special angle pairs, they're all going to be congruent angles except for one, and that's same side interior angles. And those are supplementary. One other thing to remember is that you need to be able to recognize that 1 and 3 vertical angles, they're congruent. 2 and 3 are a linear pair. So remember, anytime you have two lines that intersect, you're going to have a pair of angles that are vertical, and you're also going to have several pairs that are supplementary. They're a linear pair. So let's take a look at our first example. The measure of angle 3 is 55. Which angles are supplementary to angle 3 and how do you know? You're going to be asked to justify your reasons, how you know certain angle measures or what, by either knowing that something's a linear pair or something's a vertical angle to it. So let's look here and let's talk real quick about our angle measures. So angle 1 and 3. Okay, we know that angle 3 is 55 degrees. Well, we know that angle 1 is also 55 degrees. They're vertical angles. We know that 5 and 3 are 55 degrees because they are alternate interior angles. And we know 3 and 7 are congruent. They're 55 degrees because these are corresponding. That means that all the other angles are going to be supplementary because they're either congruent or they're supplementary. Now, to figure out what our angle measure is, to be supplementary, you're going to do 180 minus 55. That's going to equal 125. That means that all these other angles are going to be 125. So let's go ahead and identify which ones are supplementary and how do we know. So the first one we're going to say is angle 4. Okay? And it is a linear pair with angle 3. So 3 and 4 linear pair. We also know that angle 2, for the same reason, linear pair with angle 2. Sorry, angle 3 here. Now, that marks off these two, so we got 125 here, 125 here. Next one we're going to go to over here is 8. It's next to it. It's going to be also 125. And so what is that relationship going to be? Well, and this is all going back to angle 3, so angle 3 is going to be supplementary with angle 8, and our reason is that they are same side interior angles. That's going to be with angle 3. So they form a linear pair. So once again, you look to see that they're on the same side of the transversal, and they are on inside the parallel lines. Remember, corresponding angles can be on the same side of the transversal, but one is on the inside, one is on the outside, like 3 and 7. Okay, and if they're on opposite sides of the transversal, there's a good chance that they're going to be alternate interior or alternate exterior. So the last one is always the hardest one, angle 6. And there's many ways you can actually get this. Okay, so angle 6, and the reason why is you can say that angle 6 and angle 7 form a linear pair. Which means that these two are supplementary. So this is 125 here, and we already know that angle 3 and angle 7 are congruent. So they are congruent corresponding angles. Okay, so there's not a direct relationship between angle 3 and angle 6. Yes, they're on alternating sides, but they're not. 6 is not on the interior, so it's not alternate interior. 3 is not on the outside, so it can't be alternate exterior. So we have to we have to draw that relationship through another angle. We could have said that 3 and 5 were congruent by alternate interior angles, and 5 and 6 form a linear pair. We could have said that we knew that angle 8 is a supplementary with angle 3 because it's same side interior angles, and angle 6 and 8 are vertical angles, so those would be congruent. So like I said before, there's many ways that you could have got this. Okay, so let's take a look at our next problem. What are the measures of angle 3 and 4? Which theorem or postulate justifies each answer? So in this problem here, we're going to take a look at angle 3 and angle 4. If you want to know what their measure is, the angle they give us is 105 degrees. So as we look here, we notice that angle 3 here, how is it related to 105? Well, these are going to be alternate interior angles. That means that if we know that alternate interior angles are congruent, that means that angle 3 is 105 degrees. So we put 105 degrees. Now which theorem justifies it? Well, this is going to be the alternate interior angles theorem. Now one thing that confuses a lot of people is determining how do I know which lines I'm using because there's 4 lines? Well, always look at your angle. 105 is created from this line here and this line here, line M and line B. Now I believe on your paper it should say this is going to be line P and this will be line Q, so we'll refer to it as that. So it touches line Q and line M. And then you have angle 3, which angle 3 touches line P and line M. So the one they did not use was line L. This was not used at all. So therefore, you can kind of put your thumb over this one so it kind of makes it so you're not looking at it and you're focusing just on this. So it becomes that P and Q is our parallel lines, and that makes 3 and 5 our alternate interior angles. So let's look at 4. 4 touches the line L and line Q. Okay, and 105 touches line M and line Q. So the one that's in common is our transversal, which is Q, and that makes line L parallel to line M. So that, as we're looking at this, that makes these two angles same side interior angles. So we'd say if it's going to be same side interior, we're going to do 180 minus 105, which gives us 75 degrees. So angle 4 is 75 degrees. And our reason is by same side interior angles postulate. It's the only one that's a postulate. And the rest of them are a theorem. So right now I want you to pause the video. I want you to find out the measures of A through F, angles 1, 2, 5, 6, 7, and 8. And then come back and check your answers when you're done. Alright, so if we look here, we got angle 1. It is an alternate interior angle with angle 4, which is 75, so this one is going to be 75. Then we look at angle 2. Well, angle 2 is corresponding with angle 4. We know this is 75, so we know angle 2 is 75. We could have also said that since angle 1 and 2 are vertical angles, and we know angle 1 is 75, then angle 2 should be 75. Then we look at angles, and we look at C, angle 5. Well, 5 and 105 are corresponding, so therefore this one's going to be 105 degrees. You could have also used angle 2 and 5 being a same side interior angles. They would be supplementary, so if this is 75, this has to be 105. And then we look at angle 6. Angle 6 is going to be 105 because it is alternate interior angles with the 105 degrees. It's also a linear pair with angle 4. So if this is 75, this has to be 105. Angle 7 is a vertical angle with 105, so it's also 105. And F, angle 8. So if we look here, we have a lot of ways to look at this. We can say 1 and 8 are a linear pair, 2 and 8 are a linear pair. If this is 75, this has to be 105. It can also be same side interior angles with angle 4. So these are your answers, and be prepared to be able to justify your answer by which one of your special angle pairs that it belongs to. Alright, so let's move on to the next one. This one says find the value of y. So in this diagram you were given certain information. Now one thing we want to make sure I emphasize here is these arrows. Anytime you see the arrows in the middle of a line, that refers to these lines being parallel. If we had two sets of parallel lines, you'd have two sets of arrows. So there's a lot of actual ways to solve for y. But one thing we have to recognize is when we have parallel lines and we have a transversal, we're going to end up creating those special angle pairs. Now if this is 80 degrees, that means that from here to here is 80 degrees, how far these two lines are opening up at this vertex right here. Now if this is 180, if this is 80, then this entire angle from here to here should equal 100, because the two together should equal 180. So if this is 80, subtract it from 180 and get 100. So if part of our angle is already 40, then what is the measure of the other angle? So the way we'd solve this is we'd say, we know it's equal to 100, the total, so we do 100 is equal to 40 plus y. These two added together will give me our missing angle measure, so subtract 40. And that gives us that y is equal to 60 degrees. So 60 degrees gives us the 100 that when we add to 80, it is supplementary. Alright, so let's move on to the last example. What are the values of x and y? So I want you to look at this in this trapezoid. You got two sets you have a set of parallel lines, and you've got an angle measure here. Now there is no relationship between your x and y here. Only your x is here. So try to figure out your relationship between your x's, the relationship between the y's. Pause the video, work it out, and come back and check your work when you're done. All right, so what you should recognize here, and I hope that you did, is that these two angles, the ones with x's, are same side interior angles. Now a lot of times we have trouble visualizing this because it's a trapezoid, but if you were to take and extend these lines out, then this would act as our transversal. Didn't exactly get that right, but you can kind of see this is our transversal, these are our parallel lines, so therefore these two are same side interior angles, which means they're going to be supplementary. So that tells me to solve for x, I have to add these up and set it equal to 180. So we do that and we get 64 for x. Now the next thing we have to do is plug it back in. So this angle is going to be 2 times 64, which is going to be 128. So this angle right here is 128. Now we can go back and do 64 minus 12. That's going to be 52. So that gives us our other angle. So we get 52 and 128. You can check it by adding these together, see if they equal 180. Same thing with y. 3y and y plus 20 are same side interior angles for this line. Now, like I said before, there's no direct relationship between your x and your y here. But there is between these two because they are same side interior angles. So we set it up. 3y plus 20 equals 180, and we get that y is equal to 40. So when you plug this number back in here, you're going to get 3 times 40, which is going to give us 120. So we're going to write down here 120, and then we're going to go to the y plus 20 down here, which means it's going to be 40 plus 20. That's going to give us 60. And so you should be able to tell that, because if you subtracted 120 from 180, you would be able to get 60 as well. So always look to determine what type of special angle they give me. Are they vertical angles? Are they a linear pair? Are they alternate interior? Are they alternate exterior? Are they corresponding? Or are they same side interior? And whatever they are will help you set up your expressions to solve for the variable. Since these were same side interior, and I know same side interior angles are supplementary, I'm going to add these up and set them equal to 180. If they were corresponding, then it would be equal to each other, and I would set them equal to each other and solve. So you got to know the difference between the two in order to set your expressions up correctly. All right, and that's going to conclude it for lesson 3.2.